So, welcome to this course on tribology of materials, principles and applications. So, what we are going to do is that we will have 40 lectures in this particular NPTEL course, and we will start with the very introduction of the tribology, and also we will cover the various tribological materials or whatever materials they are used for tribological applications. So, let me begin with a statement that tribology is truly an interdisciplinary field because it integrates the concepts of mechanical engineering, lubrication science as well as material science. So, what we are planning to do in this specific NPTEL course, that we will go through first the very basics of the tribology, particularly the friction, wear and lubrication, and that will be followed by several case studies, primarily from my research group as well as the research group of Professor B.V. Manoj Kumar from Indian Institute of Technology, Roorkee, where we are going to illustrate that how to develop new materials for better wear resistance applications. So, all in all, this course will be suitable for undergraduate students, senior undergraduate students and graduate students pursuing the field of tribology. I am a material scientist by training. So, therefore, many of the lectures I am going to cover in my part will also focus largely on the principles of tribology as relevant to material science, because this specific subject of tribology can be taught from mechanical engineering point of view as well as from material science and science point of view. I think it is quite relevant to state that tribology as a field is widely being pursued in various mechanical engineering departments in the world, but it is not being pursued to that significant extent in the material science departments in different universities of the world. So, therefore, it is very important for the students from material science point of view to understand the very fundamentals of the field of tribology. So, in this first lecture I will be covering some very definition of tribology as well as I will give an overview of the tribological materials. So, the first is that what is the meaning of the word tribology. So, tribology is derived from the Greek word tribos, means rubbing, and essentially tribology means the science of rubbing. So, tribos means rubbing, logos means science. So, if you combine these two things, so essentially it is known as science of rubbing. So, science of rubbing means it essentially means that what is the interaction when two solids are being rubbed against each other. Little bit of historical perspective, Leonardo da Vinci observed for the first time couple of centuries back that frictional force at the contact of two solids is proportional to the normal force. If the frictional force is capital F, then it is proportional to n is a normal force, which gives rise to this equation F is equal to mu n. We will come back to these equations later when I will teach about the friction or the theory of friction, but at this point of time it is just important to know that mu is the coefficient of friction, capital F is the frictional force and capital N is the normal load. One of the main thing in tribology that all the researchers should always remember, tribology is a system dependent property. So, what it means that friction of steel or friction of stainless steel does not mean anything unless one would ask you that what is the friction coefficient of stainless steel against alumina, or what is the friction coefficient of stainless steel against aluminum alloys, for example. So, it is simply because of the fact that friction is not a friction coefficient, that is mu is not a material property. So, it is a system property. So, it is not a material property. So, therefore, always one has to find out that what is the mating solid. Having said that, the textbook type of definition of tribology is that it is the science and technology of interacting surfaces in relative motion, and it encompasses friction, wear and lubrications. Let me spend some time in explaining you the significance of this specific statement. So, what it means that when two solids are in motion, for example, if you take a simple sphere, okay, and you have a flat surface. So, this simple sphere is pressed against the flat by a normal force N. Now, if you give some sliding motion to this particular contact, what it will have? You will have in essentially the friction force that will be acting here. So, the friction force will always be acting opposite to that of the motion, the sliding motion, because friction force is the force which will oppose the motion of one solid over another. Okay. Now, this friction force essentially, if there is, so essentially what you can consider that one solid is stationary and another solid is in relative motion. So, essentially there is relative motion between two solids, that is, one is a sphere and one is a flat body. So, if there is no relative motion absolutely, then there is no coefficient, no friction and no wear. Now, in many of the so in the field of lubrication, often people develop certain commercial lubricants which when used at two surfaces in motion, then what will happen is that these two surfaces often their interaction or their relative motion is inhibited, and if this relative motion is inhibited, that means that lubricant is not allowing the two solids to come in close contact with each other, and if it happens, then coefficient of friction can be extremely small, and it can be going to 0.001 or something like that. So, that means that essentially the surfaces become frictionless. So, some of these coatings, for example, self lubricated coatings, the motivation for the development of self lubrication coatings is to provide the surfaces frictionless. So, friction and wear, these two properties are system dependent property as well as lubrication, but friction and wear, they do not have direct correlation. What it means that a particular system, tribological system, can experience low friction but high wear, or at the same time a particular tribological system may experience high friction, but at the same time they may experience low wear. So, what it means is that they do not have no direct correlation. So, as I have explained that a same system can have high wear, but low friction. So, way back in 2011 we have written a book, myself and my colleague Mircea Kalin from University of Ljubljana, Slovenia. We have written a book which is published by John Wiley and Sons and American Ceramic Society. The name of the book is Tribology of Ceramics and Composites, a material science perspective. A few minutes ago I mentioned that tribology as a field is much more significantly pursued in the mechanical engineering community, but to a much lesser extent in the material science. So, the major motivation of this book is to provide material science perspective, to the tribology of ceramics. But there are a host of other books which are like which are written by Stackowiak and Batchelor. Bharat Bhushan has written books on principles and applications of tribology. Bowden and Tabor, they have also written another book called Friction and Lubrication of Solids. Cameron, Basic Lubrication Theory. Ian Hutchings from Cambridge University written a book on tribology, Friction and Wear of Engineering Materials. Kenneth Ludema, Friction, Wear and Lubrication, a textbook in tribology. So, many of these previous books, if you look at, often these authors of these books are traditionally from the mechanical engineering backgrounds. The same is true for Mircea Kalin, who is currently Dean of Mechanical Engineering at University of Ljubljana, but there are few people who are from material science background, but who has written textbooks in the field of tribology. One of the major books which is have much more relevant to tribology, and that is Kane Johnson's book, that is on contact mechanics, and that is published by Cambridge University Press at least 30 years ago. And this book is kind of Bible in the field of contact mechanics, and many theory of contact mechanics are directly applied in the field of tribology. So, the young researchers or students who are going to pursue the field of tribology, they make a note of the different textbooks which are particularly available in the market. Many of the research results that I am going to show you in my following lectures, these research results are the outcome of several R&D projects which are sponsored by Department of Science and Technology, Government of India, Department of Atomic Energy, Government of India, Defence Research and Development Organization, Government of India, Indian Space Research Organization, ISRO, Government of India, BrahMos Aerospace, New Delhi, also a joint Indo-Soviet venture in the field of aerospace. Also, a large number of students from ceramics background, from material science background, they have also contributed to the field of tribology in my lab, and many of them are currently faculty members in this. So, with Manoj Kumar I have formulated this particular NPTEL course. Debashish Sarkar does ceramic engineering at NIT Rourkela, who is currently professor. Ashutosh Dubey is currently assistant professor at BHU Varanasi. Suresh Babu is currently scientist at ARCI. Brahmaraju is currently assistant professor at NIT Warangal. So, these are like recent group alumni, and some of them they have also done quite a bit of tribology work in my group in recent past. So, these are the most recent people who have pursued in last 2 to 3 years the erosion wear, arc jet wear, sliding wear in my group, and first 3 of them they are from BrahMos Aerospace. I had a long project with BrahMos Aerospace, and then there is this particular guy Ariharan, he was a PhD scholar at IIT Kanpur. Tarok is doing lot of tribology work, particularly erosion, high temperature erosion on a new class of ceramics, that is niobium boride, and he is currently registered as a PhD scholar at IIT Kanpur. Ravi finished his PhD and now currently postdoc at ISC, and he does lot of these things in ISC Bangalore, also sliding wear. So, this is the book on tribology of ceramics and composites, and this book is kind of become quite popular in the community, and we are coming up with another version of this book which will be more textbook, and that is with myself, Michan Kalin and Manoj Kumar, and that will have lot of assignment problems and questions and answers for the benefit of the students. This is another book which is Advanced Structural Ceramics, and where I have also covered many of the things on structural ceramics, and this is published by John Wiley and Sons Incorporated. Now, why tribology is so important, or in other words, what is the impact of tribology in industry to start with. So, tribology actually plays a very important role in several technological applications, and some of them are listed here. Now, if you can see, these are mostly used in as different components in either large machines or some of the engineering structures. For example, the first one is the machine elements, second one is the wear parts or metal cutting tools, like some of the sarmets, I think in some of the lectures we will be using, like titanium carbonitride nickel based sarmet tools. So, this is used for the metal cutting. Now, ball and roller bearings. So, ball bearings certainly 440C martensitic stainless steel, they are used as ball bearings in space shuttles, but we have also done lot of investigations just to show that 440C ball bearings can perhaps be replaced by some of the ceramic bearings like silicon nitride balls. And there is a most recent innovation in the field of bearings, they call hybrid bearings, like silicon carbide balls, but the raceway would be ceramic. So, essentially raceway would be metals. So, this would be metals, and then there are balls which will be placed which are fixed between the two raceways, and these balls can be silicon nitride balls or Cialon balls. So, this is the concept of the hybrid ball bearings. Now, femoral stem in hip replacements, more than femoral stem, it is essentially femoral head and acetabular socket. So, this essentially combination, femoral head and acetabular socket combination, that experiences wear depending on what is the type of the materials that are used in the total hip joint replacement. So, these normally people are called THR. THR stands for total hip joint replacement. So, in this total hip joint replacement, what is the femoral head and acetabular socket combination, they are used, and that would be very important. Then rivets in aircraft wings. So, that is also a place where tribology plays an important role. Gears and seals, that is important. Traction drives, automotive brakes, piston rings, extrusion dies. So, extrusion dies, they are used for the metal extrusion, and those dies depending on what is the force, the frictional force, and this frictional force plays an important role there. Micro electromechanical systems, that is also important, and magnetic storage recording devices. So, this is MEMS and names, they call micro and nano electromechanical system, MEMS and names, though they also play an important role there in the field of tribological applications. Now, if you look at the economical aspect, so if it has an impact on the industry, definitely it will have an impact on the national economy. So, this is the kind of a very qualitative, not a pie chart, qualitative chart where different color essentially represents different aspects. For example, this red one, essentially it is decrease in losses due to stopping and starting of the machine. This one is directly related to reduction in energy consumption by reduced friction, and then there is something other things is that this one is related to the decrease in the cost of lubricants. So, from this particular angle, suppose if it is theta, theta by 360 will determine what is the total fraction, that is very important. Now, cost of maintenance and cost of replacement, that is by far the larger fraction which impacts the nation's economy, which impacts the industry as well. So, the bottom line I have mentioned here, the bottom line is that control of wear and its consequences essentially represent an enormous amount of economic benefit. So, again let me reiterate here, the tribology is a system dependent property. What you see here, that there are two solids. Okay. Let me spend some time here to explain you. There are two solids, and here I have shown you the top solid is being pressed against the bottom solid. So, if you take this is the S1 solid 1 and this is the S2 solid 2, the top solid is being pressed against the bottom solid, and what you see here, the projection of this asperity from the top solid, and from the bottom solid you see that there is a projection of the asperities here, right. So, these two asperities, they meet at certain points, and these two asperities, even this is the particular spots, asperity junctions. So, this spot is essentially, let me write it down, this is called asperity junction. So, this asperity junction, okay, this asperity junction will experience the friction depending on the load and depending on the sliding speed. This is the sliding speed here. This particular asperity junction can get knocked off, okay, and can get knocked off, and then that can lead to the wear. So, essentially these are the potential asperity junctions that leads to the, so essentially the arrow should be this way, that leads to loss of material in the surrounding medium. So, what it means is that a material, based on the whatever surface finish, based on the whatever the polishing, a material may appear to you as extremely flat, but in reality it is not extremely flat. In many literature they are mentioned as the material is nominally flat, but nominally flat materials also has a finite number of asperities, and these asperities have certain radius of curvature and also and surface height. So, if you blow up this particular asperity here, this will be having like this. So, this is your height h, and there is also radius of curvature here. So, this radius of curvature is very important. Okay. This radius of curvature is very important, and this height is also very important, and depending on the radius of curvature and sharpness of the asperity, the coefficient of friction that will generate. So, what you see as the complete total frictional force, this total frictional force essentially is a summation of the local frictional forces here at different asperity junctions. So, as I said before, the tribology is an interdisciplinary field, and its interdisciplinary nature can be attributed to the fact that the fundamental disciplines of this tribology is a metallurgy, material science engineering, physics and chemistry, and also on the other hand mechanical engineering. Why physics and chemistry? Because many tribological interactions, like what is the frictional force that will be generated, what is the physics of these mechanisms, you need to bring a lot of physics concepts, physics based concepts. Why chemistry is important? Many lubrication design or the fluid lubrication, what is the lubricant additives that you use, what is the EP additive, extra phase additives and all those things. So, those things requires lot of knowledge from the chemistry. Now, metallurgy and materials engineering, from there you can develop matting materials and that will have surface properties. Mechanical engineering, that will lead to the tribological environment, mechanics at the interface, contact mechanics at the interface. So, this is the contact mechanics at the interface and operating parameters. Now, these two interaction essentially lead to the friction at tribological interface and wear of matting solids. So, essentially the interactions between matting solids and interactions between tribological environment, that will result in the friction and wear. So, importance of scale in tribology. So, if you start with the physics and chemistry at the surface is the nanoscale. So, you have the real area of contacts. So, if you go back to the previous slides where I have shown. So, this is that actually nanoscale interaction. So, this is the places this is called nanoscale interaction. Then if you go to the interactions at the atomic scale, then it will go even larger interactions at more in that in the atomic scale is a micrometer. Then contact size is the millimeter scale, and then mechanical system that will be at the centimeter scale. So, you go from physics and chemistry of surfaces to surface mechanics to solid mechanics. So, nanotribology essentially means friction and wear of relative surfaces, friction and wear of surfaces in relative motion, but at the nanoscale. Whenever that mechanism operates at the nanoscale, we call it as a nanotribology. What are the different tribological testing machines? So, this is more from experimental research point of view. You have a pin on disc, which is by far most commonly used machines in the laboratory. So, this is your pin, and this is the unidirectional motion stationary pin, and this is the rotating disc. So, this is a pin on disc. So, this is the pin on cylinder. So, you have a pin here, you have a pin here, and then this pin, it is pressed against the drum or rotating cylinder by force. There is a pin on cylinder. This is called pin on plate. So, it is essentially this is a reciprocated motion, sliding motion. This is your force N. So, this pin is placed against that, and this is your 4 ball tester, and this 4 ball is this 1 ball is here, and this is 3 ball. So, this 4 ball tester is widely used for the lubrication testing. This is the commercial machine. So, this ball is pressed against the flat, and this one of these matting solids is rotating here, and here in this particular case disc is rotating at certain speed, rotational speed like RPM, and then as a result ball and flat, this particular system experiences friction and wear. So, we will come back to the next lecture to some time. Thank you.